I would like to put away and understand and have an agreement with you on, because this is basically the first steps in algebra. Okay. This is called a binomial, and it's a binomial squared. So what do we know the result is every time we square a binomial? Okay, we don't remember. So today is the 27th. So let's take a look. Is this a binomial? Yes, this is a binomial. A binomial has two terms. In other words, two quantities that are added or subtracted. So if we have two quantities that we add or subtract, we call them terms. And two terms. And then the name of adding or subtracting two terms is a binomial. So this is a binomial squared. How do we square binomial? If I ask you to square 2, you're going to say 2 times 2, correct? If I'm asking you to square a plus b, what would you say? Please, Will? Bill. Multiplied. Good, indeed. A plus b times a plus b. So now we're looking at multiplying two binomials. Now what? How do I multiply two binomials? What do I need to do? What is the procedure of multiplying two binomials? Please. Absolutely, perfect. The FOIL method. Good. So how do I do that? Can anyone dictate? It's a times a, which is copy the base and what happens to the exponents. Copy the base and what? Add this. Very good. Add the exponent, so it's a squared plus a times b, which is yes, plus b times a, which is right, or ab, they're the same, plus b times b, which is good. So then from here, I continue here. And can anyone tell us anything about that? How do I simplify this expression? Can anyone say, oh, you simplify by writing? Say it again. Good. Excellent. We combine like terms. Awesome. So, can anyone dictate this expression? Simplified? What is the first term? Very good. What is the second term? When I add an apple to an apple, what do I get? 2 apples, 2ab plus b squared. Good. So now imagine that I do not have a. This is no longer a. I'm going to call it ft. What do you think ft means? First term. I'm going to change b into, what do you think? Very good. Awesome. And now squared. And now I want you to say, I no longer want to FOIL. I want to write the formula right away. What would you tell me to write? Tell me and I'll write it. All you have to do is look at this pattern and tell me what to do, what to write. Say it again. There is no more a. I have ft. Very good. Ft squared. I have to copy this symbol. Good. What is the symbol? What is the symbol? Good. Plus, then I'm not there. I'm here. I have to copy everything, just replacing this with FT and this with ST. And that is the pattern. So what will you tell me to write? 2, very good. What else? FT times ST, very good. Then I'm here with plus. What will you say? Very good. Awesome. Now I want you to give me an example. Make up an example. Not A, not B, not FT, not ST. Make up an example. Okay, 3y squared plus. Give me a second term. Any term. 2x squared. Awesome. And everything's squared. So now what is FT? Can anyone read the FT for us? 3y squared, right? That's the FT. Good. Can anyone read the ST for us? Perfect. Now can anyone fill it in? No foiling. You tell me what to write and I'll write it. So what are you going to do with FT? You're going to square it, right? Good. So how do I square a product? This is not a binomial. This is one term. How do I square a product? It's not the same method. This is for a binomial. But how do I square 3y squared? So 3y squared squared is, I have to square the first factor, which is 9, and I have to square the second factor. I copy the base, and now what happens to the exponents? No, I add them when I multiply, but this is not multiplication. See? So a times a, I copy the base, and 1 plus 1 is 2. But here, I have y squared squared. So I copy the base, and what do I do with the exponents? No, I add when I multiply. A times a, I copy the base, and I add the exponents. 1 plus 1 is 2. But this is different. I have y squared squared. So I copy the base, and perfect. That's it. So when I square, I multiply. Or when I take to a power, I multiply. Good, so then the first term. Can anyone dictate the first term? And I'll put it in. Yes. Very good. Thank you, Bill. Now, can anyone tell us what to write for the second term? Yes? Times? Say it again. But this is FT. You jump to ST. I'm not there yet. This is your ST, the 2x squared. But I have to put in the FT first. So what do I have? So 3y squared, very good, multiplied by, very good, plus, I have 2x squared squared. So in the same way, what do I get? Excellent. Now I have to simplify this a little bit, and I'm done. And I learned how to square binomial without foiling. This is a very valuable tool or skill to have. So 9y to the fourth. Can anyone give us the simplified form of the middle term? Ready? Plus. How much is 2 times 3? How much is 6 times 2? Good. So then 12x squared y squared plus 4x to the fourth. So what is the conclusion then? A binomial squared equals what? What is this? How is this called? How many terms does it have? Very good. Yes. Yes. Brian, you wanted to say something? Very good. So from now on, we remember that binomial squared is a trinomial, which means that when we see something like this, we will not write this. Correct? Totally wrong. Because this is a binomial. It's a sum of two terms, squared. And what is this? Is this a trinomial? No. So now, not to be confused with this. This is a totally different story. This is easy. I square 2, I square x, I square y. That is easy. But squaring a binomial is not that easy. Look, I have to come up with 3 terms. I have to be very careful. And I'm hoping that moving forward, no one will say, how did you get the 12? X squared, y squared. Where does this come from, right? We know where it's coming from. Where is it coming from? From AB plus AB, which is 2AB. That's where it's coming from. 2 times the first term times the second term. Does it make sense? Yes? We'll have more examples in a minute. So then what will you tell me to write in our agreement? What will you say again? A plus B everything squared equals? Can anyone dictate? Perfect.
Plus 2AB.
Perfect. That's it. So we have to remember this. How do I remember it? Okay, at first I'm going to remember it like a tune. I'm going to say first term plus second term, everything squared is the first term squared plus 2 times the first times the second plus the second term squared. I'm going to repeat this while driving in my car, right, or doing something, and it will stick at some point in time. I will remember it. What if I have minus? What do you think happens here? Oh, the light here creates a problem when I have my own tent. Here it is. Okay. Good. So, what do you think this one will come out to be? Which one? Which one? Yes. Which one will be negative? Not the first one, and not the last one, because negative b times negative b will be still positive b squared. But which one will change? Not the first one, because a squared, a times a is a squared. That's not going to change. The middle one, just the middle one. Yes. Yes, just the middle one. So can anyone dictate this? Yes? 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 So negative b times negative b will always be plus. Thank you, Juan. Very good. Well done. Okay, so let's look at an example. Can anyone make one up? Okay, I will. Gonna make it 3y cubed. 4x minus 3y cubed. With no foiling, I would like you to tell me what to write. And you can say, what do you have against foiling? And nothing. But the factoring will be very difficult if we continue foiling this. So can anyone give us the first term? Yes, already simplified. What is it? We know how to square 4x. I know that. So what is it? Well, yes, but 4 squared, I cannot just square something that I like and not square something that I don't. When I square the entire first term, not part of it. So what do I have when I square 4x? 16x squared. Good. The next is the sign. What is the sign? Very good. What will you write? Let's write it out first. Just dictate what to write. Yes? And moving forward, we're not going to ask where does the 2 come from, right? Where does the 2 come from? From adding these 2 like terms and getting a 2 in front, right? We know that. Good. 2 times what? Times? We already took care of the sign. Very good point you're making. We already took care of the sign. So once this is minus, if you put another minus, it will change into positive. Yes, please.
Why did you write 4x?
Say it again.
Why the 4x? 2 times 4x?
We're not multiplying. We're squaring 4x. So 4 squared is 16. X squared is x squared. Was that the question?
Yeah.
So we're squaring, not multiplying. Good. And then the last term, plus what? Please square for me 3y cubed and tell me what you get. 9. Copy the base. What do we do with the exponents? Very good, which is 6. Now we have to take care of the middle term. So simplify it for me and tell me what to write. So it's 16x squared and then? Yes, please. Well,
Minus 24.
yes. Yes. Plus 9y to the 6th. Very good. Awesome. We'll have more examples. I'll ask you to make one up again. So now let's finalize the last one. Okay, so let's look at the last one and then look at examples. Okay, obviously the last one is different. Would you agree? It's not a binomial squared. It's basically the same binomial, one with plus and one with minus. So let's say we don't know what this is. So let's FOIL it first. How much is a times a? Good. How much is a times negative b? Very good. How much is b times a? Plus ab. And how much is b times negative b? Very good. Now look again carefully and say, oh, I see what happens now. What happens now?
The 2 middle terms cancel.
This is the difference of squares. Very good. Awesome. Difference of squares. Difference of squares. Good. So let's look at an example with difference of squares. That's my page 2. Can anyone give us an example? So maybe I should write it with, like I did before, with first term, second term. Okay, so let's look at an example with first term plus second term multiplied by first term minus second term. What will you say? Oops, no one can see it. Sorry about that. So what will you say this is the pattern, and we will have to remember it? What will you write? All you have to do is look here. See the pattern and tell me what to write.
Are you talking about like random terms or?
No, not yet. Just with a, like we did before. See here? We did this with the first term plus second term squared, and we said first term squared plus 2 times the first times the second plus the second term squared. So we can see the pattern, because if I have minus here, then I have minus here. And this is the pattern for both, top two. But now what will be the pattern for this, for anything? Anything here that is the same here, otherwise I cannot use this special product. So if these two are not the same, and if these two are not the same, and the only difference is not plus and minus in any order, minus or plus or minus, it doesn't matter, I cannot use the special product. So what will you say this equals to then, in general, for anything, as a pattern that we should remember? Yes, yes, yes. Very good. So now I know the pattern. So now let's make up an example. So what does this say? What example you want to make up? Anything? Okay, I'm going to say 2x minus 3. And what should the other one be? What do you think? But then we cannot apply this. See the pattern? First term plus second term, first term minus the second term. If I don't have this, the result will never be the difference of squares. So these two have to be the same, just the difference is the sign. So then what should the second binomial be? Of course, with no foiling, because we understand the pattern, what will you tell me the result is? Say it again. Careful. When I square x, I have to square 2. So 4x squared, and then minus 9. And this is the difference of squares. Very good. Any questions for me? I'd like to look at some examples from 1.1. There is so little time in this class. There is so little time for what I would like to do with you. So little time. Okay. I'm going to just look at, let's say, problem 14 on page 102 and 22 for now on page 102. In 14, we have y equals x squared plus 2. The problem is asking us to graph, and the other one is -2, the absolute value of x. So now, before we really continue with this, do we understand these three special products and how they work, and how to apply the special product and no longer FOIL? Yes? Are you going to look at other examples or create other examples when you get home, like 3 or 4 examples, and fill this in? At least 3 more examples, one with plus, one with minus, and the other one with a difference of squares. One of each, at least. Okay. So, good. So in here, we're asked to basically recall what we did in a previous class, in a prerequisite class, how to graph these. First of all, are these functions? How do I identify whether it's a function or not? We're going to discuss this again in chapter 2. But does anyone remember how we identify whether an equation represents a function or not? Do we remember? Okay, well, a function requires for each x value only one, for each input only one output. So for example, if I have in this equation, how do I know it's a function or not? If I say x equals 1, how many y values will you give me? How do I evaluate this for x equals 1? What do I need to do? The answer is plug it in. Perfect. So 1 squared plus 2. By the order of operations, I have to square 1 first and then add 2 to it. So what will be y? Very good. So if I continue forever, let's say x equals 0, how much is y? 2. If I say x equals negative 2, how much is y? Yes, negative 2 squared is positive 4. 4 plus 2 is 6. Very good. So I can continue forever. Do you think that now, after looking at few x values, few values of the input, do you think that this is a function? For each x value, I will find only one y value, not 2 or 3? Yes, for any x, I will get one y value, right? Not two y values. I can replace x by anything I want. And the y value will only be 1, whatever it is, but just one value, correct? Okay, what about this one? So this is a function. What about this one? Do we remember the symbol? What does the absolute value of x represent? What is the definition of the absolute value? What do we say? Oh, the absolute value is the distance between a number and x, between 0 and x. Distance between 0 and x. So if I say, what is the absolute value of 3? What will you say? How many units? What is the distance between 0 and 3? 3 units. If I ask you what is the absolute value of 0, you will say, what is the distance between 0 and 0? What would you say? 0. What about the absolute value of negative 6? What is the distance between 0 and negative 6? And the distance, I cannot say that the distance between me and Ryan is negative 5 feet or negative 10 feet, right? So it's just 6 because it's the distance. Good. So is this a function? What do you think? If x is 0, I'll have the absolute value of 0 times negative 2. If x is 2, I'll have the absolute value of 2 times negative 2. So will you say that this is also a function? Yes, it's also a function. For any x value, there is only one y value. For any x, there is only one y. Therefore, it's a function. Okay. So let's start by graphing the second one. I only have 3 minutes left. So let's start by graphing the second one, and then we graph the first one next time. So y equals negative 2, the absolute value of x. Now, whenever I'm asked to graph a function, and this is extremely important, if you ask me, graph this function, what do you think my first thought will be? For any function, what will be my first thought? Okay, so let's say I want to travel to New York. I want to take a flight to New York. What is my first question that I ask myself?
How far?
Right, but if I have the money, right? Do I have the money to pay for the ticket or not? So the same thing here. Do I have the input? What is the input? What can I plug in this function? Where does this function exist? Right? Because functions not always exist for all real numbers. So my first thought is, in graphing a function, first step is domain of the function, which is the input. What is the input of this function? So let's look at it and say, okay, what can the input be? Can I plug in 0? Yes, because I can find the absolute value of 0. Can I plug in 5? Yes, because the absolute value of 5 exists. Can I plug in 10? Yes. Negative 3? Yes. Negative 15? Yes. So what is the domain of this function? That's my first step, first thought. Do I have the money to go to New York? whatever, by any means. So what is the input? What do you think the domain of this function is? Of course. This is how we write all real numbers, from negative infinity to infinity. That's my first step. My second step is, once I identify the domain, I will create a chart, a table of values. So I can show my students or my professor what I'm doing, what values I pick. So that's my second step. First step, what is the input? Is it restricted? Many functions will have a restricted domain. They will not exist for everything. So for example, we'll get to look at, again, at the square root of x. I can't plug in -4. It doesn't exist. So this function will not have domain or real numbers. I cannot plug in -3. I can plug in anywhere from 0 to infinity. So since you said all real numbers, I'm going to write this. And now I pick what I want. It is wise to determine the x and y intercepts, among other ordered pairs that you want to use. But that's a wise, those two, if they are different, they may be the same point. The x and y intercepts may be in this case, and they will be here, the origin. So I do start with the origin. And now let's say I go to -2, -1, 1, and 2. That's more than enough. So I know I have to stop. But for next time, just plug in these numbers and tell me what you get. And then we will